Hello everybody, this is the notes for section 4.3, Algebra 2 Trig, talking about the inverse of a matrix. Alright, an inverse matrix is the same idea as a reciprocal. If you take a number and multiply it by its reciprocal, you get 1. Alright, that's the idea of an inverse matrix. So, keep that in mind. First, a couple of terminologies that have to go along or go before this. So, a square matrix, same number of rows, same number of columns. The identity matrix it's a square matrix, and it has ones along this main diagonal. And you can see these highlighted pictures here. Those ones, that is the main diagonal. Okay, you got a 2 by 2 matrix C. Here, main diagonal. Those are nothing but ones, zeros everywhere else. For a 3 by 3 matrix, this is the identity matrix. Ones along the main diagonal, zeros everywhere else. Same thing for a 4 by 4. Okay, that is what an identity matrix is. If you relate matrices and numbers, the identity matrix I, it is equivalent to the number 1. Meaning, if you multiply a number by 1, you get the same number. 5 times 1 is 5. With this is supposed to be an I. My board's not working very well. That looks even worse. It's the letter I, capital letter I. When you multiply a matrix by the identity matrix, you get the same thing. And that's what we're looking at down here. It's called the identity matrix for multiplication. If you were to take matrix A and multiply it by the identity matrix, it doesn't matter if you go A times I or I times A, you're getting the same thing, okay? It's just like multiplying by a number by 1, all right? That's how it works. So, just to show you, I'll do this by hand here, row by column. So, negative 3 times 1 plus 4 times 0, that is negative 3. All right, first row, second column, negative 3 times 0 plus 4 times 1, that is 4. Second row, first column, 8 times 1 plus 2 times 0, 8. Second row, second column, 8 times 0 plus 2 times 1, 2. If we call this matrix A, we just got matrix A again. That's the idea of the identity matrix. Okay, so, like I mentioned on the very first slide, right in the very beginning, an inverse to a matrix is like the idea of a reciprocal. We take a number and multiply it by its reciprocal, we're getting 1. So, when we talk about matrices, you take matrix A, multiply it by its inverse, and the notation for an inverse matrix is, it looks like it's a negative 1 exponent. Again, it's not an exponent, it's just notation. You take a matrix and multiply it by its inverse, you're getting the identity matrix. Okay, and that's what is done here. You have A times the inverse of A, and you are getting the identity matrix. So, two matrices are inverses of each other if you can do both of these. You go A times B, you get the identity matrix, or you do B times A, you're going to get the identity matrix. And again, you're looking at this notation. That is inverse notation. You just say it, A inverse. All right, so I want to show that C and D are inverses of each other. So I'm going to bring this calculator up. Go on. I have already entered in the matrices. So I'm going to go secondary matrix, names, C, and I'm going to multiply it by D. So I'm going to go back to matrix, names, D, C times D. And there's your identity matrix. This is 1, 0, 0, 1. All right, so CD equals 1, 0, 0, 1. That's ones along that main diagonal, zeros everywhere else. That's the identity matrix. But it's got to be the other direction also. It also has to work when you do D times C. When we do that, there it is. D times C equals 1, 0, 0, 1. Also, the identity matrix. So, C and D are inverses of each other. You have to do both of these things to guarantee that it is the identity. So we could write matrix D as C inverse. We could write matrix C as D inverse. They are inverses of each other, so it doesn't matter which one. All right, let's get rid of the rabbit calculator. All right, finding the inverse with a calculator. Well, let's bring the calculator back up. To find the inverse of a calculator, it's pretty easy. I've already entered in matrix A, so for you, you got to enter it in. You go to matrix. If you're going to enter in a matrix, you go over to edit. I've already entered in matrix A, so I'm just going to go to names, hit enter. There is matrix A. I want to know what is the inverse of it. So the notation is A inverse, that little -1 in the exponent position. The button that you're hitting for matrices, that x to the -1, right there. Whoops. Well, the arrow doesn't go over the calculator, but it's this x to the -1 button. You hit that, it puts that -1 there, you hit enter. There's your A inverse, okay? That's all you need to do to find the inverse. So, -2.5 to 1.5, -1. Now, these are halves. You can easily put them into fraction form, but if you go to math, enter, turn that answer into fractions, -5 halves, 2, 3 halves, -1. Okay? Fairly easy. There is ways to find the inverse by hand, and you will be doing that in the homework problems. They give you the formula. It's not a big deal, just a couple of calculations. But you can use the calculator to find the inverse. All right, the next idea is this thing called a determinant. Basically, what a determinant does is it's going to tell you if a matrix has an inverse or not. There's a lot of other stuff. I was reading up on it today. The determinant, it gets into a lot of theory. Some of the stuff is actually very useful, but it's also very, very complicated. It's very high-level mathematics. So for our purposes, the determinant of a 2x2 matrix, it will tell you if the inverse exists or if it does not. And so this first underline down here, matrix A has an inverse if and only if the determinant of matrix A does not equal 0. Okay, meaning if the determinant equals anything else but 0, the inverse exists. Okay, here's how you find the determinant. It is AD minus BC. When you have a 2x2 matrix, you just label those entries A, B, C, and D. AD minus BC is the determinant. So, looking at this example here, does the inverse exist for matrix A? All right, so this is A, B, C, and D. We do A times D, -3 times 8. This is for the determinant of A. -3 times 8 minus B times C, 4 times 6. -24 minus 24 is a -48. I'm fairly certain -48 is not 0. That means A inverse exists. Don't really know what it is yet. We can find it, but at least we know it exists. All right, we'll talk about some of this stuff in class. That's the end of the notes for today. This is about as difficult as it gets. There's some other plugging in numbers, like I said, but for the most part, it's following an algorithm. So not too difficult. Hope everybody has a good night, and I'll see you in class tomorrow.